Hello class, welcome to this last part. So we're going to do the EOC review, part 7. This should be the last part in the series. So we'll be able to finish the rest of the packet. So 7.3, graph and solve mathematical and real world problems modeled with the equation of a circle. Determine and interpret key features in terms of the context. All right, so more equations of circles essentially. So the equation of a circle is given. Which of the following statements are correct? All right, so let's take this equation and then let's separate the x parts and then the y parts, and then let's move this to the right hand side to make so that we can get it out of the way. So I'm going to subtract it out. So x squared minus 10x. Put the x parts together and then the y parts together. Give yourself some room so you can complete the square. Y squared plus 4y plus blank, and then equals, and then since I'm running out of room here, I'm just going to put equals negative 78. That's this right hand side. 0 minus 78. Remember, I moved that over. And then I'm going to put the two blanks so that I can complete the square and then put it on the other side as well. So remember, it's going to be the middle number divided by 2 squared. Middle number divided by 2 squared. And then whatever you do on one side, you got to do on the other side. You got to balance it out. So 10 divided by 2 is 5. 5 squared is 25. So x squared minus 10x plus 25 plus y squared plus 4y. 4 divided by 2 squared is 4 equals negative 78. And then this is plus 25. This is plus 4. This is a typo, guys. This should not say 78. I just realized this should say plus 20. So that's a typo. Make sure you fix that. So actually, if I subtract 20 on both, so if I move it over, it's going to be negative 20, okay? So this should actually say negative 20. All right. So there's negative 20 plus that. Okay, so this is going to be negative 20. So in this case, if I add those together, I'm going to get... Oh, wait. So since... it's not going to be 20, it's going to be negative 20. I apologize. Negative 20. So then if I move it over, it's going to be plus 20. Okay? Negative and plus cancel. So this is going to be positive 20. Again, I apologize. So this is going to be positive 20. And then if you add this, it's going to be 49. All right. And then we're going to basically, to factor this out, we need two numbers that when you multiply to 25 but add up to negative 10. That's going to be negative 5 and then negative 5 and then negative 5. So multiply 25, add it to negative 10. So it's going to be x minus 5 times x minus 5, which is to the second power. And then this one is two numbers that multiply to 4 but add it to 4, which is 2 and 2. So it's going to be y plus 2 squared. Just going to rewrite it down there. And so the center is 5, negative 2. Remember, it's negative because that 2 is positive, which means that it should be, it reverses to negative. Because remember, the equation of a circle has negative in it. So if this is positive, then you got to switch the sign. All right. Okay, and then the radius is equal to the square root of this 49 here, which is 7. Okay, so the radius is 7. The center is not 5,2 nor not negative 5,2, so that's not the answer. And then domain of the circle and range. Okay, so they're asking a lot of stuff here. So let's graph this circle real quick in order to be able to understand how to do E and F. So if I graph the circle, the center is at 5, negative 2. The radius is 7. So 1, 2, 3, 4, 5, 6, 7. So it's like over here, which this is 5. So 5 plus 7 is going to be 12. This is going to be 12. And then 1, 2, 3, 4, 5, 6, 7. So this is going to be negative 2. So, okay, so then this is going to go over here. So the radius is 7, 7. And then I got to go up 7 as well, right? 1, 2, 3, 4, 5, 6, 7. So this is over here. and then go down 7, 1, 2, 3, 4, 5, 6, 7, which is going to be at -9. And then I can draw my circle with a radius of 7. Sorry, this actually goes here. So notice that the domain are the x values. So the largest x value is 12. The smallest x value is -2. So the domain is between -2 and 12. That's true. The range are the y values. So this is y, this is x. So the largest y value is 5, and then the smallest y value is -9. So that is not true, right? So the answers are A and E. All right, so that's range and domain. Okay, so those are more algebra concepts. So I'm actually surprised that they actually asked that question in that, because I get these questions from the book, you know. So so we went over all the different questions. So some chairs surrounding a fire pit form a circle that can be represented by the equation. The fire pit is the center of the circle formed by the chairs. What point represents the location of the fire pit? So they're just talking about the center, right? The fire pit is the center. So the center here is, remember, it's the formula is x minus h squared, y minus k squared equals r squared. And then this is the center. So it's going to be 2 and 6 because the negatives match. If the signs do not match, the answer is going to be negative. If the signs do match, it's going to be positive. So it's going to be 2 and 6. At which point could another chair be placed so it lies on the circle? Select all that apply. So basically what we're going to do is these are all x and y values, and we're going to plug them into this equation to see if it equals 25, okay? So we got 0 minus 2 squared plus 10 minus 6 squared equals 25. So this is going to be 4 plus 16, which does not equal to 25. So this is not an answer. Now I'm going to do this one, but I'm going to do this one over here because I'm running out of room. -2 minus 2 squared, 3 minus 6 squared equals 25. Let's figure out that's true. So this is going to be 4. 4 squared is 16. This is going to be 3. 3 squared is 9. 16 plus 9 is indeed 25. So this is on the circle. Let's do this one. 2 minus 2 squared plus 6 minus 6 squared equals 25. Well, that's the center of the circle, so this is going to give us 0, right? 0 does not equal to 25, so that's not true. Let's plug this one in here. So 0 minus 2 squared, 0 minus 6 squared equals 25. So it's going to be 4 plus 36, which is not 25, so no. And then we'll do 7, 6. So we'll do that over here. Let's do that over here, actually. 7 minus 2 squared plus 6 minus 6 squared equals 25. 7 minus 2 is 5, so 5, and then 5 times 5 is 25. 6 minus 6 is 0, and 0 squared is 0, so 25 equals 25. So that's true. And then last one, we got to plug it into here. 6 minus 2 squared plus 3 minus 6 squared equals 25. So 6 minus 2 is 4. 4 squared is 16. 3 minus 6 is 3. 3 squared is 9. 16 plus 9 is 25. Yes. All right, so that's how you know if given a point, if it lies on the circle, is if it satisfies the equation of the circle. All right, the equation of a circle is given. Determine whether each statement is true or false. So we're given this, so we're gonna group these together, and then we're gonna group these together. Okay, the y's and the x's get grouped. So x squared minus 6x plus blank plus y squared plus 10y plus blank equals 2 plus blank plus blank. So we're going to add the numbers here to complete the square, and then we're going to repeat those numbers on the right side. So remember, it's going to be middle number, which is 6, divided by 2 squared. Middle number divided by 2 squared. That's the trick to completing the square. And then repeat those here. 6 divided by 2 squared is 9. 10 divided by 2 squared is 25. You get 2 plus 9 plus 25. And then, so when you add those, that's 11 plus 25 is 36. Then we're going to say two numbers that multiply to 9 but add up to -6. And that's going to be -3 and -3. It's going to be x minus 3 times x minus 3, which is x minus 3 squared. Then for this one, two numbers that multiply to 25 but add up to 10, which is going to be 5 and 5. It's going to be y plus 5 times y plus 5, which is y plus 5 squared. And now you can see it's of this form. In this case, h in the 3 match in sign, so h is going to be equal to 3. And then these do not match in sign, so that means it's going to be -5. And then r squared is 36, which means that r is equal to 6 because you got to take the square root. All right, so the radius is 6, that's true. The center is 3, -5, that's true. The range, we'd have to draw it, so we'll get back to that later. The center is at -3, 5, no. The domain, okay, so we got to do the drawing so that we can figure out whether the range or domain is true or not. So let's do the graph over here. So radius is 6 and center is 3, -5. One, 2, 3, 4, 5, 6. So the radius is going to be, the radius is 6. So it's got to be up 6 here. It's got to be over 6. 1, 2, 3, 4, 5, 6, which is going to be at 9. It's got to be over 6. 1, 2, 3, 4, 5, 6, which is at -3. It's going to go down 6. 1, 2, 3, 4, 5, 6, which is at -11. Okay, so the lowest y value is -11. The highest y value is 1. That's the range. So the range is from -1 to 11. That's true. Oh wait, it's not from -1 to 11. I'm sorry. It's from -11 to 1. So this is actually false, right? And this is false as well. All right, and then the domain is from -3 to 9. So the smallest x value is -3. The highest is 9. So this is going to be my answer. All right, that takes care of number 3. All right, so saving the easier one or the quicker one for last. So we know the equation, the standard form for a circle. And so see that these signs don't match, so that means h is -2. So the center is -2. These numbers don't match, so it's going to be negative. So we got the center is at -2 and -4. And the radius squared is 16, which means that we got to take the square root, so the radius is 4. So we're going to go 4 out on each side. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And then we can graph our circle. Oops. All right, and that's it. That takes care of page 39. So now we're on to the trig standards, trig benchmark. So the T is for like the trigonometry stuff. So T.1.1, define trig ratios for acute angles. This benchmark is all about SOHCAHTOA. So as long as you know how to do SOHCAHTOA, you're good. SOHCAHTOA. So we're dealing with tangent, which is TOA. Tangent is opposite over adjacent, right? And they want the value of tangent of A. So this is the angle A. So tangent of A equals opposite over adjacent. The opposite side is this guy, and the adjacent side is this guy. So it's going to be 2 square root of 22 over 9. That's it. Pretty straightforward. What is the sine ratio of angle P? So sine is SOHCAHTOA, so that's opposite over hypotenuse. So sine of P equals opposite over hypotenuse. Opposite is this guy, and then hypotenuse is the longest side, which is 17. So it's going to be 15 over 17. All right, number 3, what is the cosine ratio of Z? So SOHCAHTOA. So we got cosine of Z equals adjacent over hypotenuse, which is, this is adjacent, this is hypotenuse, or this is opposite, sorry. This is hypotenuse. So this one we had to actually find the hypotenuse because they don't actually tell us. But it's not too bad. It's A, B, and C. A squared plus B squared equals C squared. So we're going to use a little Pythagorean theorem here. A squared plus B squared equals C squared. So we got to take the square root to solve for C, right? So C is equal to the square root of all this. So 12 times 12 is 144. 16 times 16 is, I believe it's 256. So we're going to add those together. We get 400, and the square root of 400 is 20. So this is 20, which is my hypotenuse. So it's going to be adjacent over hypotenuse. So it's 12 over 20. Don't forget to reduce the fraction. We got to divide this by 4, top and bottom. And then our final answer for the cosine is going to be 3 over 5. Oops. So it's going to be A. All right. So let's do last one in this series here. Complete the table given in a diagram. So we want to do the sine of A. So sine of A. Remember, sine is SOHCAHTOA. So sine is opposite over hypotenuse. So if this is A, the opposite is this guy, and the hypotenuse is the longest side, which is that one, and this is adjacent. So sine of A is equal to opposite over hypotenuse. Of course, we don't like the square root on, well, 9 divided by 3 is 3, so this is going to be 3 over square root of 13. We don't like the square root on the bottom, so remember, to get rid of it, we got to multiply by the same square root. But whatever we do on the bottom, we do on the top. So we got this 3 times the square root of 13. And then square root of 13 times square root of 13 is 13. That's going to be your sine. Okay? And then we'll do cosine. Cosine is adjacent over hypotenuse. Adjacent is 6. So 6 over hypotenuse. 6 divided by 3 is 2. So this becomes 2 over square root of 13. And then multiply by the square root because we want to get rid of it. We don't like the square roots on the bottom. Just kind of glue them on the top. On the bottom, it's going to be 13. And then finally, we got tangent of A, which is opposite over adjacent. So it's going to be opposite is 9, adjacent is 6. And then we just got to reduce the fraction and we'll be done. Divide by 3, top and bottom. 9 divided by 3 is 3. 6 divided by 3 is 2. We got 3 halves. All right, and that's it for that benchmark. So moving on to page 41. The next benchmark is T1.2. These are like word problems involving trig ratios and stuff like that, and Pythagorean theorem. All right, so Jack's eyes are 5 feet above the ground. So this is it's essentially his height. So 5 feet. He's looking up at a building, and the building is has a height of h, right? Actually, let's draw the building. So I'm going to draw the building here. Let's say that's the building. Okay, so I said that's the building, and the height of the building is h, and his height is 5, which means that, and then we know we're going to make a right triangle out of this. Okay, so now we got a right triangle. And you notice that this height here is the height of the building minus his height of 5. So this is actually h minus 5. If you, does that make sense? So if the total is h and this is 5, then this part is whatever h is minus 5. So that's the height of this triangle, this right triangle. And then it says that the angle of elevation of his line of sight to the top of the building is 67. So this is 67 degrees. And it says that he is standing 400 feet from the base of the building. So he's standing 400 feet away. So using this right triangle and this right triangle only, we can see that we have, so let me just kind of redraw that triangle over here. We have h minus 5, we have 400, and that's all we have. So using that right triangle, we see that this is opposite and this is adjacent. So this is going to be tangent, TOA, tangent. So the tangent of 67 degrees is equal to O over A, so H minus 5, over A, which is 400. All right, and there's our equation, and so we just have to solve that. So we're going to multiply by 400 on both sides to get rid of it. And then so we have 400 tan 67 equals H minus 5. And then I want to solve for H, so I'm going to add 5 to both sides. Now this 5 does not add up to the 67 or the 400, guys. These are two totally separate things. So my H is 400 tan 67 plus 5. Those are two separate things. We got to calculate 400 tangent 67 on the calculator, and then we're going to add 5 to that number. Okay, if we do that, we get 947 feet. And that's how tall the building is. All right, so number 2, Garrett makes a ramp for his skateboard in the shape of a right triangle with a hypotenuse of 2 and a leg of 1. Okay, there's the ramp. Hypotenuse is 2, the leg is 1. He wants to use a trig ratio to describe the relationship between these two sides. Select all the expressions that he could use. Well, first off, you might notice that this is actually a 30, 60, 90 triangle. This is a special right triangle, guys, because this side is double the leg, which means that this side, this is actually 60 degrees and this is 30 degrees. Okay, because remember, in a special right triangle, in the 30, 60, 90 triangle, this side is A and this side is 2A. So if this is A, this is double. So since if A is 1, then this is going to be 2, which is exactly what we have here. So it's a 30, 60, 90. And in order to, and it says which expression could he use for 1/2? Well, you could do opposite over hypotenuse, right? So opposite over hypotenuse, and that's going to be sine of 30. So sine of 30 is opposite over hypotenuse. That's going to give you 1/2. Let me draw this triangle again. If I were to do cosine, this is not a 45-degree triangle. This is 30. And tan of 30 is opposite over adjacent. We don't have the adjacent, right? So we're not going to use that. We're not going to use a 45-degree angle either. Let's do cosine of 60. Adjacent over hypotenuse. Yeah, so it's going to be 1/2. That's true. Tangent of 45, we're not using that angle. So those are your two answers. All right, Michaela is shooting a paintball gun at a target in a tree. Michaela's point is at point G, and the target is at point E. Assuming her paintball shoots straight, what angle should she aim at in order to hit the target? Round to the nearest 10. So what angle should she aim at? That angle there. So what is that angle? We'll call that angle X. So remember, this is opposite over adjacent. So we got, that's going to be tangent. Tangent is opposite over adjacent. So tangent of that angle, which is X, equals 28.2 opposite over adjacent. Remember, the only way to get rid of tangent is to do the inverse tan. So we're going to do the inverse tangent on both sides. And that cancels. And then we're going to plug that into the calculator. Inverse tan of 28.2 over 45.8, and you get about 31.6 degrees. All right, number 4, the angle of elevation from a viewer to the top of a building is 50 degrees. So this is the guy or gal. Again, top of a building. And then they're 80 feet away. The viewer is 80 feet away and the viewers are 5. So what is the height of the building? And it says the angle of elevation is 50 degrees. And this is a right triangle. So if I just focus on this right triangle, if the height of the building is H, then this is H minus their height, H minus 5.5. So I'm just going to focus on this triangle. And if I focus on this triangle, then I have opposite over adjacent. So that's tangent. Tangent of 50 degrees equals opposite over adjacent. And there's our equation. So we'll multiply by 80 on both sides to get rid of it. So we get 80 tan 50 equals h minus 5.5. Then we'll add 5.5 to both sides. And that'll give us h. So we're going to do 80 tan of 50, whatever that is, plus 5.5. And you do that on the calculator, you get 100.8 feet. All right. So number 5, a 30-foot long escalator forms a 41-degree angle at the second floor. Which is the closest height of the first floor? So this is like x. We'll call this x. So this is going to be adjacent over hypotenuse. So katoa, that's cosine. So cosine of 41 degrees equals adjacent over hypotenuse. And to solve this, we just got to multiply by 30 on both sides to cancel it. And just do this on the calculator. So x is approximately 22.6 feet. So 22.5 feet. All right, number 6, the picture shows a hamster sliding down a ramp. What is the distance in feet that the hamster has to travel to move from point A to point C? So we want to move from point A to point C. So we'll call that distance x, okay? And so we have, that's the hypotenuse, right? So this is opposite, and then that's hypotenuse. So that's so katoa, so sine. So we have sine of 40 is equal to 15 over x. All right, so we want to solve for x. So remember, we got to do the Lynch swap. If the variable is on the bottom, then we have to swap those. So let's do the Lynch swap. So x is equal to 15 over sine of 40 degrees. Okay, all right, and then we're gonna match this up. So it's 15 sine 40, so that's not it. 15 over cotangent, no. 15 over secant, no. The answer is actually B. I'll tell you what these mean, okay? Because we haven't really talked about them much because I don't think they're really gonna emphasize it as much on the EOC. But just in case they do, I wanna go over it. So we know about sine, cosine, and tangent, right? So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Well, there's 3 other trig functions that sometimes we use. And they are cosecant, secant, and cotangent. Okay? So cosecant is the reverse of sine. Okay, so cosecant is the reverse of sine. So I'm going to put these in red to show you that they're similar, and these in green. Okay, so cosecant is hypotenuse over opposite. And then secant is the reverse of cosine, so hypotenuse over adjacent. And then cotangent is the reciprocal of tangent, so it's going to be adjacent over opposite. So if you do the reciprocal, it gives you the other trig function. All right, so in this case, that means that whatever cosine is, so whatever sine is equal to, then you just have to flip it to get the cosecant, and vice versa, right? So if I know whatever cosecant is equal to, it's the flip of whatever sine is. Okay, so they're flips of each other, basically. So in this case, I can rewrite this as 15 cosecant of 40 because this is on the bottom, and so if I flip it back up, then it becomes cosecant. Okay, so that's what that is. So if you ever see that, then just note that that's what that means. Hopefully they won't give you that on the exam, but I just in case. All right, so number 6, the diagram below shows a ramp connecting the ground to a loading platform 4.5 feet above the ground, and then they give you the length of the ramp. So they're looking for determine to the nearest degree the angle of elevation formed by the ramp and the ground. So we're trying to figure out that angle. So we'll call that x. All right, so this is opposite. This is hypotenuse. So that's a sine, SOHCAHTOA. So that's going to be sine of x is equal to opposite over hypotenuse. The only way to get rid of sine is by doing the sine inverse. Whatever you do on one side, do on the other. So x is equal to, just do that on the calculator, inverse sine of 4.5 over 11.75. And you get 22.5 degrees. All right, and then the next page is a honor standard, so we won't have to do that. We can skip it. And then I think the one after that is also another honor standard, if I'm not mistaken. Yep, so another honor standard. So we are almost there, guys. So we're on page 44. Identify and accurately interpret if, then, if and only if, all and not statements. Find the converse, inverse, and contrapositive. This is what we did in the beginning of the year. You may recall the logical stuff. So, okay, so it says which statement is the inverse of the given conditional statement. So let's review all of those real quick. So remember that inverse, so normally you have an if-then statement, right? If-then statement, which means if P, then Q, right? That's what that means. If P, then Q, or P implies Q. Well, the inverse is the inverse is when you negate both of them. So you're going to do a negation. So not P implies not Q. So if not P, then not Q. That's another way to say it. And then the converse is basically when you reverse the two statements. So that means Q implies P. So instead of doing P implies Q, you just reverse it. And then the contrapositive is when you do both the inverse and the converse. So you reverse them. So you do the converse, and then you do the negation. So not Q implies not P, and that's how you do it. So here this is P and this is Q. So if I spend too much money on P on art supplies, so if P, then Q, my parents will be unhappy. So if I want to do the inverse, then I just got to negate both statements. If I don't spend too much money, then my parents will not be unhappy. I just got to do I just got to negate it. So if I do not spend too much money, then my parents will not be unhappy. This is my answer. The converse in this case would be reversing them. So if my parents will be unhappy, then I will spend too much money on art supplies. That's the converse when you reverse them. And then the contrapositive is you reverse them and then negate it. So in this case, it would be if my parents are not unhappy, then I will not spend too much money on art supplies. And that's the contrapositive. So just to give you some extra examples. Which statement is the contrapositive? So this is P and this is Q. So we got to do not P, not Q implies not P. So in that case, Q is going to go first and then negate it. If I do not set the oven to 400, then I will not be baking a chicken breast. Okay? So if you are not baking the chicken breast, no. If you do not set the oven to 400, then you're not baking a chicken breast. That's C. All right, which statement is the inverse? So the inverse, again, is not P implies not Q. This is P, this is Q. So if the lines are not perpendicular, then the lines are not parallel. All right, number 4, which statement is the converse? That's Q implies P. That's when you reverse it. So if this is P and this is Q, then you got to reverse it. So if it is a rectangle, then it is a square. So if a polygon is a rectangle, then it is a square. So it's either B or D. However, which one is true? So let's see. If a polygon is a rectangle, then it is a square. Is that true or false? Well, if you have a rectangle, does that mean that it's guaranteed to be a square? And the answer is no, only sometimes. If all of the sides are the same, then it's a square. Otherwise, it's just a rectangle. All right, so the answer is B. That is false. All right, that is it for logic, I think. So the next one is an honor standard. We don't have to do construct proofs, so including proofs by contradiction. So we're good on that. And here we go. This is the last one. All right, so it's gonna be a shorter video than the rest. All right, consider the figure. Based on the information given, which statement represents the conjunction not R and P? So remember, this means and this means or. If it's a V, it's like or. If it's like a upside down V, it's an and. So this means not or and P. So not R. Okay, so that means it cannot be this. It says not R, so that means that they're not congruent, right? And the lines are parallel, so that's how you interpret that. So AIF and CJD are not congruent, so that's the not R part. And lines K and L are parallel. That's statement P. So that's A. So it's actually A. Now, is this conjunction true or false? Well, let's take a look. So this is not R and P, right? So is R true? Meaning, are the lines, or are they congruent? Well, let's take a look at them. So AIF, so we're looking at this angle, and CJD. Are those two angles congruent? Well, we know that since these are parallel, that's true. Those are actually parallel because they tell you that they're parallel. So this is actually true. P is true. Then that means that this, and we know that this angle is congruent to this angle because of vertical angles. And if these lines are parallel, then that means this angle is congruent to this angle. And that's because they're corresponding angles. And therefore, by transitive property, this angle is congruent to this angle. So yes, that is true. However, R is true, but they wanted you to say not R. So that means not R means it's false. So we got false and true. So here's the thing about and. If you have true and true, that means you get true. If you have true and false, you get false. If you have false and false, you get false, okay? So both of the statements have to be true in order for the overall result to be true. If one of them are false, if one or both of them are false, then the entire statement is false. So since we have one of them false, the answer is that it's false. For or, if you had or, true or true is true. True or false is true. If one of them are false, it's still going to be true. False or false is false. Okay? So which value provides a counterexample to the following statement? Select all that apply. All prime numbers are odd. Remember, a prime number is a number that only 1 and itself go into it. So for example, 8 is not a prime number because you have 2 and 4 that goes into it. But however, 2 is a prime number because you cannot break it down further, right? It's just going to be 2 and 1. So that's what we call a prime number, is only 1 and itself go into it. Nothing else other than those two numbers go into it. So this is actually a prime number. The 4 is not prime because you can break it up into 2 times 2. So it's not prime. It's called composite. All right, so 2 is a prime number and it is not odd. So this serves as a counterexample. A counterexample is an answer. It's an example that refutes the statement. So that means this is refuting the statement that it's odd because this is an even number. 3 is prime, but it's an odd number, so it doesn't serve as a counterexample. 7 is a prime number, but it's odd. 8 is a composite number, as demonstrated here. 13 is prime, but it's odd. 22 is composite. So the only counterexample is 2. All right, determine whether each conclusion is valid or invalid based on the information given. All right, so given. If you use 1 cup of water, we'll say that's statement P, then you should use 2 tablespoons of honey and glycerin. If you use 1 cup of water, that's the same statement, so we'll call that P as well. Then you should use half a cup of gum arabic. All right, so then we'll call this statement R because we already have Q for the 2 tablespoons. It says Minnie used 1 cup of water to make her watercolor binder. Okay, so we got P implies Q, and then P implies R. Those are 2 separate things. It says Minnie used 1 cup of water to make her binder. If you use half a cup of gum arabic, then you should use 2 tablespoons of honey and glycerin each. So if R, then Q. Is that true? Well, the answer is no, it's not true because these are the true statements. P implies Q and P implies R. This is not logical from these two, right? This is the original statement. So you have to use this to determine the validity of this statement. So P implies R, but R doesn't imply Q. So this is invalid. If you use 2 tablespoons of honey, so that's Q, then that implies that you should use half a cup of Arabic. So does Q imply R? No. P implies R, but Q doesn't imply R, so that's invalid. Minnie used 2 tablespoons of honey and glycerin. Is that true or false? Well, it says that Minnie used 1 cup of water, so that's P. She did do that. So if she did do that, then that means that she must do this and she must do that, right? Because she started with the 1 cup of water. And that implies Q, and that also implies R. So she has to do both. So she has to do the 2 tablespoons of honey, which in this case is Q. So if she did P, then she must do Q. So that is true. Okay, so it's all based off of the statements. If one happens, then the other happens. If, that's what it says. And that's known as the law of detachment, okay? So what we just did here, this here is known as the law of detachment. The law of detachment basically says that if P happens, then Q will happen. Okay, so if they said P implies Q, and P happens to occur, then that means Q will also occur. That's the law of detachment. Okay, so for example, if I said that if you don't do your chores, you're gonna get grounded, that's the P implies Q statement. Well then, let's say Susan decides to not do her chores. What's gonna happen to her? Well, based off of the law of detachment, which is based off of this, she's gonna be grounded. And that's what the law of detachment says. All right, so number 4, is the conclusion valid? So it says if it is Wednesday or Friday, that's P, then Sarah is going to go to physical therapy. So P implies Q. If P happens, then Q happens. It says that Sarah went to physical therapy today. So that means it must be Wednesday or Friday. Is that true? Well, it says that if it is Wednesday or Friday, then she goes to physical therapy. But does that mean that if she went to physical therapy, that it implies that it's Wednesday or Friday? The answer is no, that is not guaranteed, right? She could go to physical therapy and it not be a Wednesday or a Friday. However, if it is Wednesday or Friday, then for sure she will go to physical therapy, right? So that is the law of detachment. But this is invalid, right? Because we don't know whether it's Wednesday or Friday. We have to know that it's Wednesday or Friday to be able to say that she goes to physical therapy. But if she goes to physical therapy, that doesn't mean that it's Wednesday or Friday. So it's invalid. All right. So we use the law of detachment here again. However, let me talk about the law of syllogism. The law of syllogism states that if P implies Q and Q implies R, then that means that P implies R. Okay? So for example, if P is I have enough money, and then Q is I will go to the grocery store, and R is I will go to the movies. Then it says, then the statement says, if P implies Q, meaning if I have money, then I will go to the grocery store. And if I say that if I go to the grocery store, then I will go to the movies, well then this implies that if I have money, I will go to the movies. And this is true, okay? So that's using the law of syllogism. It's sort of like the transitive property, but for logic. Okay? So that's what that is. All right, guys, that is it for the video. I hope you, thanks for enduring the 7-part series. Hope you learned a lot, and as usual, I'll see you in the next one.